0 from my balance. So that's a new balance, a new encrypted data. You emit an event and the coprocessor computes your new balance without knowing your existing balance. And even someone looking wouldn't know whether I had sufficient balance or not because my balance would change, right? And so the balance, as in the encrypted value of the balance, lives in the coprocessor, and the handle lives on the public blockchain. The computation is asynchronous, right? So you can create as many, FHE handles as you want on the public blockchain. You would emit the events, and then the coprocessor will execute them as it gets them. And the advantage of that approach compared to the previous one is that you can scale horizontally the FHE coprocessor. So, today we can run about 100 transactions per second on a GPU. If you need 1,000, you put 10 GPUs. I mean, hopefully, and we're talking about, in 6 months to a year, our FPGA will be able to handle 200 to 300, and then in a few years, an ASIC could handle tens of thousands. So that's, but when we looked at it in terms of at least, tokenization space, you rarely have, high numbers. Like 100 TPS is probably the max that you see on, fairly popular stablecoins. So we're already able to tackle a lot of the real world, transactions. Obviously, if you move into, say, a retail of public securities, maybe that number has to be, 10 to 100x higher. But so on the technology side, I described how to execute operations. But obviously, you need a starting point, which is the inputs, how to submit inputs into the blockchain. And that happens, basically on the browser or on the endpoint of the client. The end user will encrypt his data using a public encryption key. They'll then call the gateway to store that encrypted data, and they'll get the handle. In the process, the end user will also prove that he knows how the encryption process has been done. So there is a ZK proof that the end user generates on its browser to prove that he knows the clear data and it is related to the encrypted data. Why that is so that to avoid people taking someone else's encrypted data and using it. So now the end user has proven that the data is valid and that he knows the clear value. He got a handle and he submits the handle together with the signature of the gateway that this is correct to the smart contract. And that's how you get an input into Ethereum or into any public blockchain, right? So
how about private blockchains? You said that it doesn't matter whether it's public or...
Yeah, it's whether it's public or, technically, many of the, clients, prospects that we discuss with are, sitting in between public and private. So think of it as a bank wants to operate with multiple other banks, and they want to do it in a trusted way, but they don't want to necessarily have all the other banks see all the transactions. And so they go for a shared blockchain that is technically private, not available to everyone. Technically, it's also permissioned, so only the banks are running the nodes. And they'll be running their own KMS, their own coprocessor to be completely independent from the rest of the world.
Okay. I had a question, well, a couple of questions just to level set understanding. There's quite a lot on this page. Can you just explain a bit better that green arrow on the left that says call smart contract? What's the input data that's actually going into smart contract? Is it the ZK proof and the encrypted inputs? And in terms of EVM and token standards, have you had to modify any of the interfaces in these token standards to accept these new types of input? Is there like a ERC FHE 20 type of version? Like what have you had to do to adapt the EVM to support that?
Yeah, no, great question. So the first one, and sorry for this graph, is a bit too condensed. So I'll probably share a version that has step by step. So the green is, submitting an input flow. So it starts with you call the gateway with an encrypted data. So the actual encrypted data. Let's say I want to transfer 5 tokens. I need to encrypt 5. I encrypt 5 with a public key, but I also generate a zero-knowledge proof that the encrypted data corresponds to 5. Without disclosing that it's 5, but at least disclosing that I'm the one behind the encryption. So I call the gateway. The gateway will store the encrypted 5, right? So now I have stored the encrypted 5, and it will check the ZK proof to confirm that it's correct. So the encrypted data is correct, is valid, and I've generated the right proof. And it will send me a signature together with the handle that proves that the gateway is confirming that the handle is okay, is correct. I then use that handle to call the smart contract. So the first thing that the smart contract will do, it will get the handle, it will get the signature, it will confirm that the signature is correct. And from then on, it will use the handle as a representation of an encrypted data. So in the case of I want to transfer 5, first it will check that the handle that I sent that is representing the 5 is correct. And then it will use that handle to compare to my balance and reduce my balance and increase your balance.
So the handle is just an identifier to data.
Correct.
Cool. Okay.
Yeah. So now the second part of the question is, what did you do? What did we need to change? So initially we thought the handle could be, a 250 is a 256-bit representation. We thought we could hack the ERC20. So instead of sending an integer, you just send the handle. But the truth is, the ERC20 is very specific. An amount, the integer is an amount. So it's not a handle of an encrypted data. So we decided together with partners to create another standard that is pretty much the same as the ERC20 in many regards. But instead of using integers, we're using handles. So you will find the usual functions that exist in an ERC20. So transfer, balance off, mint, burn, etc. But instead of using integers, you'll be using encrypted integers, handles, right? And so that's the thinking of how to build the interface was done by OpenZeppelin because they have a lot more experience than we do in terms of what has worked, what hasn't worked, how they would have written the ERC20 standard if it was to be written today versus 15 years ago. So all this knowledge that they have helped us get quote a better confidential ERC20 because they added allow, they added certain things that are typically used when you are a token issuer. And so yes, there is they submitted the ERC 7984 to the Ethereum Foundation. And basically, we're still at the draft stage. So the ERC is being discussed. It's being discussed, and we'll see on the next slide, with ecosystem partners. So that because we wanted to make sure that we understand the use cases and whether the ERC will fulfill these use cases. So I mean, if I'll just the ERC 7984 that I mentioned. So we decided to quote open source it or submit an ERC because what we've seen is that very often people come up with a new way of doing confidentiality, and there are multiple ways, and many are good. We don't. The problem is that whenever you create a new way, you end up lacking all the tools and all the ecosystem to actually use that confidential token. And so we thought, let's create a confidential token association. Let's create an ERC that is technology agnostic. And let's make sure that, the ecosystem builds around that ERC, irrespective of how the encryption is done. Because remember, it's just a handle. The handle could be representing an FHE encrypted data. It could be representing an AES encrypted data. It could be representing computation on TEEs. It could be representing computation on MPCs. We talked with you guys, Kaleido, at one point, because you could also do it, if you have basically a reference to the amounts and the balances somewhere on a server for regulators to check. That could be the reference. So you could just have a reference to an encrypted data. It doesn't have to be computed, it's just a reference so that you have a quote, clean way of calling the reference if there is an investigation, or calling the reference if you want to do whatever decryption. Today in the Confidential Token Association, in terms of tech providers, there is Zama, Phoenix, and Inco. Inco is going for TEE, for example. They decided that they wanted to tackle certain use cases where, TEE's, privacy or security was good enough, and they needed faster but less secure, and they went their way. It's compatible. So if one day you use a tool that is compatible with ERC 7984, you will be able to actually decrypt our tokens, our transactions, but also their tokens and their transactions. And that's really the spirit. And we're talking, so the association is open. So we're talking to 3 other technology providers. We don't call them competitors because honestly, the confidentiality space is so nascent that it's more important to build together, an ecosystem rather than to fragment the ecosystem and just make it impossible to use. So the ERC 7984, we're still in the draft phase. We're collecting feedback. We got very valuable feedback from Custody Solution because they said, hey, from a regulatory point of view, we need to be able to display the amounts and the transaction values because we might get a call from a regulator or from a law enforcement, and we might need to display that. So we had to take that into account inside the standard. So it's not, we don't hack, MPC or whatever. It's really inside the standard. There is an explicit way for the smart contract to give an authorization to do decryption to a third party. We have worked with, so I mentioned Custody Solutions. So today, DFNS, Taurus have implemented the standard are implemented the standard in their solution. There are 2 other, major custody solutions leaning towards that as well. On the bridges side, Layer 0 has accepted to adopt the standard. So if you're familiar with the Layer 0 OFT, there will be a confidential OFT, so a cross-chain transfer of confidential tokens. On the wallet side, we're having discussions. Unfortunately, I cannot disclose the names yet. But so all this is to basically create an ecosystem that is compatible with the standard, irrespective of what technology you end up using for the encryption.
Okay, that's really good. If you come back just to the previous diagram,
yeah.
Can you explain this signature that gets returned and what are the trust models? So the signature that gets passed in from the gateway back to the end user that gets passed in the call smart contract. So this smart contract on chain, you are programming with some sort of authority that validates that signature. And is that like, how is that managed? I can see like there's an MPC based and identities. Can you talk a little bit about that and how that's managed?
So it's two things. The first one, on the MPC side, we talked so far about encrypting data and manipulating encrypted data, but obviously, if my balance is encrypted and I want to know my balance, I need to be able to decrypt it, right? In our approach, there is just one encryption key. It's public. And then the decryption key is sharded. So you have nodes that have a shard of the private decryption key. So each node will perform two things. If I want to decrypt something, they'll first check that I have the right to decrypt. So we have an ACL, an access control list, that is created by the smart contract. So the ACL lives inside the Ethereum chain, and that's why it's put in red, update access control. So inside the smart contract, when I modify my balance, I remove whatever amount that I'm sending you, and I have now a new balance, I have to explicitly say that this new balance can be decrypted by me inside the smart contract. So that one day, if I want to decrypt, all the nodes of the KMS can go to the, if I want to do a decryption request, they go to the KMS, they go to the ACL and say, does Ghazi have the right to decrypt his balance? Yes. Then I'll do a partial re-encryption to the keys of Ghazi, and then all of them do the same. And then I basically get an aggregated re-encrypted balance, and then I decrypt it with my private key, and now I can see my balance. So the KMS is there to allow decryption at one point, and we're using basically MPC protocol because we're sharding the private decryption key so that no one has ever the possibility of decrypting the data without the collaboration of the other nodes. And therefore, no one at any point can see the decrypted data when it comes to my data. You can see the data if the smart contract requires a decryption, because eventually if it goes into the Ethereum, it will be visible. But if I request to see my balance, then only I will be able to decrypt the re-encrypted balance and see that, I transferred 5 tokens to you. Is the KMS clear?
Yeah, the KMS part is clear, yeah.
So on the signature is just a proof from the gateway that, from the gateways, that the ZK proof is corresponding to the handle. To be honest, I'll have to defer the answer to the question because I am not the engineer in charge of that part. I'm not in the engineering side, but I'll send you an email to confirm how, how is the authority behind the signature.
Okay, cool. Yeah, I have more questions.
In any case, I mean, our code is open source. It's on GitHub. So, sometimes, if you don't trust the answer, you can check the answer on the code. That's how we see it.
Sounds good.
Yeah.
Thanks.
And I think that's really about it. In a nutshell, we're going live in a few weeks on Ethereum. So we're already live on Sepolia. Sepolia is a great, testnet. We're going live on Ethereum, and then we're adding the other EVMs in Q1, Q2. So basically, the way we add an EVM is we deploy a Zama library that any smart contract can call to emit the events, for FHE operations and for ACL updates. And we basically listen to these events and feed that into the coprocessors.
So, Ghazi, regarding this open source movement and the community that you are building, what's your biggest need or expectation regarding the growing the community? You more are looking for the source code contributors, or maybe you are more looking into building the group of companies that are in the same area, and as you mentioned, in this confidentiality space, you want to grow the awareness. And
so it's to be honest, it's standardization. We and maybe the ERC 7984 will evolve. if everyone wants to do this in a certain way and we want to do it another way, can adapt. But the truth is, what is preventing confidentiality in blockchains is the fragmentation. I mean, it's already difficult to start, let's agree on how we want to represent confidential data in a smart contract or in a token. Is really important to be able to then get some, adoption by industry. And so the approach we're taking is really, let's build the ecosystem, and everyone is obviously, we're happy to see quote competitors join the ERC 7994 and have a version of that confidential token that is compatible so that they can benefit from the rest of the ecosystem. So it's more about adoption. It's the proverbial chicken and egg problem, right? Custody solutions, exchanges, wallets, whatever you call it, will not implement before there is usage. There won't be usage before they're available. And so we have to push the usage on one standard instead of 10 or 20 different implementations.
And how the concept of confidentiality can somehow relates to the concept of transparency in the blockchain. So isn't somehow orthogonal to the usual business cases that blockchain supports? I mean, the DeFi, the finances, also the supply chain tracking.
Yeah, so the transparency is there, right? Because you can recompute everything. So you don't need to trust, the whole point of transparency in a blockchain is I don't need to trust the validators. I can run the computation myself and I'll reach the same outcome as the validators. There is an orthogonal concept though, which is anonymity. I don't know which address communicated or transacted with which one. And that we are not addressing. We're not ideological about it. Any mixer, any, privacy, any could implement both. So it could have anonymity in one dimension and confidentiality in the other. What we've seen so far is that regulators are a bit edgy when we talk about anonymity, because then it's a lot harder to trace things. And so they want to have their ways of tracing, which is why we're not at all into anonymity. Also remember, in many cases, there is an omnibus custodian behind the accounts. And so the anonymity in a way is there just because you only see one address transacting with one address. Think of it as two financial institutions talking to each other. You only see the transactions between the institutions, not between the individuals. But so anonymity is possible, but it's not what we're pushing. And I'm sure there is space for another ERC just to define how. Ethereum may want to tackle anonymity. I know that stealth addresses is an option. And so there are avenues, but we're only on confidentiality today.
Okay. So the biggest goal for now is to standardize this ERC 7984.
And to create the ecosystem, right? So, that's why we're having all these discussions with all these ecosystem players, because when, you talk to a bank, they tell you, okay, we're using Taurus as a custody solution. Are you compatible with Taurus? If you're not, you may not even get to the POC stage. Right? And same thing with DeFi, same thing with exchanges, same thing. So all of them have certain expectations. And so if you're already meeting these first expectations, you have a higher chance of moving to demonstrate that the technology can fulfill their needs.
So I think that regarding kind of just spreading the word about your initiative, we can connect with the people inside Linux Foundation Decentralized Trust that really are quite active in the standardization bodies. And even today we have Thomas on the call. I believe that Thomas will be able also to spread the word about ERC 7984 and maybe connect with some internal folks on
that would be great.
Yeah,
That would be great.
absolutely. Actually, thanks, Dominic. And it just really occurred to me when I was listening to it. And sorry for the delay. I'll check the recording
worries.
later.
No worries.
I was on another call. But yes, absolutely. This is what we're here for. It's open source. We gather the community around to discuss standards, right? Because standards can be defined in isolation. So I think maybe, Gazi, we can have a separate call about it, and we can explore how we can help you and plug you into our ecosystem. This is great. And yes, thanks, Dominic. So exactly that's what we're here for.
By all means. Thanks, Thomas.
Sure.
All right, so Gazi, excellent call, excellent talk, and we'll also distribute that internally, so other people will also have the chance to rewatch it. And of course, as Thomas said, he will connect with the people that are very much into the standardization on LFDT side.
All right. Thanks a lot, guys. It was a pleasure talking to you.
Thank you.
Bye-bye.
Thank you.
Thank you.
Bye.
Bye.
So Shane, I think that we'll be wrapping up, yeah. The meeting.
Yeah, it was
And we can
interesting.
You already left. This was the kind of experiment, because I also wanted to open those meetings to the people that are still in the open source space and are kind of much connected to the blockchain technology. So Gazi, they reached out to me from Zama, and I decided to kind of invite them. I think that's good.
Very relevant. Yeah.
We'll be looking for similar kind of people for the subsequent meetups, and I hope that it's a good direction. So.
Oh yeah, I think it's great. Thanks for that. Do you have his email by any chance? I'll just reach out and see if I can.
Yeah.
Super. Thank you. Great. And
Yeah, I think it builds some bridges between ecosystems.
Yeah.
Because when I visit the website, I see it's a very well-funded startup or company, but I never heard of it. So it's very interesting. There's so much going on.
Yeah, indeed. They gathered kind of a big amount of funding. I first heard about them like a month ago. Yeah, they reached out to me. So they've been in that kind of stealth mode, or they are in the very niche area.
Right.
I'm wondering how it compares to, I think, Paladin. Yeah, I need some time to think and to compare, like, what are the trade-offs between all those solutions? Because we once had Kaleido talking about Paladin in a meetup we organized, but it's already a bit far again. So I need to refresh my knowledge about that. But it's very interesting.
All right, so we can wrap up. Thank you, Shane, for coming. I know it's late in Japan, so but I hope that you are enjoying the time there.
Yeah.
See you next month.
Very good.
Yeah. See you, and thanks for organizing. Apologies again for the delay, but I'll check the recording.
Yeah, no worries. Thank you, Thomas. Have a good day.
Great. Thanks. Have a good one. Bye-bye.